Hey, welcome back to Math with Patrick. Today is October 27th, and we're solving problem 300 from the Daily Epsilon calendar. And all we got to do today is show that we have 27 edges on this graph. A little bit of graph theory vocab here. An edge is essentially just a line segment that connects two points. These points are called vertices, and the amount of edges attached to a vertex is called that vertex's degree. So here we can see 1, 2, 3, 4, 5. Is there 5 or 6 here? Hold on. 1, 2, 3, 4, 5, 6 edges attached to this vertex. So the degree of this vertex right here is 6. And I think for this whole diagram, all of the vertices have degree 6, right? We have 1, 2, 3, 4, 5, 6. We already counted that as a 6. 1, 2, 3, 4, 5, 6. And so 1, 2, 3, 4, 5, 6, all of these vertices have degree 6. And that's kind of convenient here because instead of just adding up various different numbers, we could just use multiplication here. The one thing to keep in mind, though, is that the total sum of all the degrees of the vertices isn't going to be the same thing as the number of edges, because if we take a look at just any given edge, we'll notice that we're double counting it, right? Because we counted it here, like again, if we're only summing up all of the degrees, we're counting that edge once over there and then once over there. So that naive approach of just doing 6 times, and I think 9, because there are 9 vertices in the diagram, won't actually give us our answer because every single edge has been counted twice. However, if we just divide by 2, now we're actually going to get the number of edges on this graph. That's just going to be 54 divided by 2, which is the same thing as 27, and that's today's date. There is another way to solve it, though, if we really wanted to. Like, we could start with any vertex, count the 6, and then just double check that we're not double counting any edges as we move around the graph. So like this vertex is not connected to that one, so this one still has 6 like new edges that we haven't encountered. But then this vertex is connected to both of the previous ones, and so we only have 4 kind of new edges here. And we could work our way around the diagram and kind of just count the edges that way. Although I feel like this strategy of just dividing by 2 in the end goes a little bit more quickly. So anyways, that's my solution. I think we're all done, and I'll see you tomorrow. Bye.